convert it, say 1 volt equivalent to say 10 meter. Right? Then you say, okay, now I got 1 volt and I multiply by 10. That's my 10 meters. So there's conversion factor there. Okay, so you go to your computer. Alright, and then I give a command to a actuators. So now I need a power. Sensor need power. My actuator need a power. Then I give a command to the feedback force. Then I say, okay, I have feedback force U, now push it M. Now do that. What kind of command force I need to give to the system? If I have the measurements called Y, I'm going to my computer, and then my computer will tell actuator, say, okay, now give me a force Y, push it M. This we call the feedback control. There's 3 things in the feedback control. One is sensors, one is actuator, one is the microprocessors or computer. To complete the feedback control. And all 3 of them require power. So this we call feedback control. Now, the second one here we call direct feedback. What do you mean direct feedback? We have a displacement feedback, we can have acceleration feedback, we can also have a velocity feedback. And they are all different sensors. So we have a sensor measurement come in, then we multiply by a constant term, then feedback. We call direct feedback. So I'm going to define all kind of different feedback for you, then what kind of control we can have. Let's look at the displacement feedback first. Now we have a system. Now we also have a sensor. We measure Y. Then we we have a computer, and we say U equal to KY. Can I do that? This is a measurement device. U is a KY. And then also, okay, my actuator, give U to the system. And U just simply KY. K is a constant. How much is the constant? That's the control engineer has to compute a gain K. And what is the gain K we're supposed to have? All right, that's the feedback force equal to constant times the output. That we call direct feedback, direct output feedback for this system. So we have actuator, we have sensors. All right. Now let us look at just the direct feedback. U equal to W happen to be say equal to W, or Y equal to W. I'm measuring the displacement. My Y sensor, I have a displacement sensor to measure displacement. Then I command it. I say, okay, give me U equal to minus K1W. It's just simple like that, right? K1. Then what system I got? Then my closed loop system is equal to MW dot plus parenthesis K plus K1 and parenthesis W equal to 0. And W1 is a positive number, positive value. This is my closed loop system. What did I change? What do I change? Huh? What did I do? The solution is this. That's my solution. What did I change? If I did use this feedback, what did I do? I changed what? Huh? I changed only frequencies. I changed frequencies from square root of K over M to become square root K plus K minus 1. Okay, now. What did I do? Did I do anything? Did I do anything good or anything bad? I changed this my original frequencies, this original system. After I have displacement feedback, then I become K plus K1 over N. And this is my cross loop system. Now the question is, if this omega 1, if that omega 1 is exact what I want to do, K1 here, I assume K1 here, this K1 here, K1 here, I assume this is positive values. If this is positive value, then my frequencies is increase or my frequency is decrease. What did I do? Do I increase my frequency or do I decrease my frequency, reduce my frequencies? In K1 larger than 0, you increase your frequencies. So this feedback allow me to increase the original system frequencies. So that's the only thing I can do. If I have direct displacement feedback, what I can do is to change my frequencies. So my system here is mimic to, this feedback is mimic to this system, exactly the same as the system, the passive system, the TMB like this. In other words, for this feedback, I add a frequency, a spring. I add a spring K1 to it. Right? Okay, so if you want to change frequencies, you want to use this TMB, or you prefer to use feedback? Let me know. You want to use feedback, or you want to use just this TMB? If I just want to change the frequencies. Right, so it depends on your objective. If I want to change frequencies from time to time, then use the feedback. If I say I want to change frequencies for good, that's it, then use the TMB later for the more one, because that requires no power. And this requires power. You want to change frequencies, you have the power to do it. If you don't change your frequency frequently, then you rather use the this that we call the passive TMB rather than active, the active one. But this one, this feedback gives a message. What message? If you have only displacement feedback, you can change your frequency. I mean, displacement, direct displacement feedback, you can change only frequencies. You cannot change anything else. Right? If you have direct displacement feedback, you change only frequencies and no energy dissipations. Well, sometimes it works okay, right? If you 101, if you know the earthquake frequencies is 5 hertz, and your 101 is happen to be 5 hertz, hey, I'd rather change to 10 hertz. So I avoid this 5 hertz. Then it's working too, although you don't add damping to it, but you stay away from the frequencies. So it depends on your objective. But The key is no energy dissipation in this feedback. This feedback, you won't dissipate the system energies. Okay, remember that, huh? All right, if I have acceleration feedback, I have, my feedback is minus W M1 W double dot. My measurement. All right, my measurement is Y W double dot. My computer say, okay, now give me the force U equal to minus M1 W double dot. And assume M1 also is a positive value. I'm talking about concept here. I'm not talking about many mathematics here. So the solution is this. So for acceleration feedback, now you also change the frequencies. This is displacement feedback. All right. This is Excel feedback. Excel feedback, critical system K over M, we change to K over M plus M1. I assume M1, but M1 can be negative, can be positive. And I assume this M1 is positive. That means you lower the frequencies if you use acceleration feedback. Okay? And what does that mean is this mimic to what? This mimic to I add another M1 at the mass M. Again, no energy dissipation. I change on the frequencies. If your control objective is to change your frequencies, and this direct feedback is good. If I want to do the control of the active feedback to the system, and that allow me to change the frequencies,